This is a module 4, investigation 8, talking about the inverse of exponential function. Okay, so we talk about the inverse functions already, right? So uh, inverse function means there are two functions are inverse, which means x and y has been interchange each other. Okay, so let's go to the logarithmic functions. So when we have a logarithmic functions, actually is from the inverse functions. So when you have an inverse function like this, it's already been interchange of when y equal to b to the x power, okay? And then we got this for the inverse, and then you can actually solve for y that y we have to mention the y is coming from the exponent, so you have to use a log for the other side. And then same base b, which is right here, becomes right here, and then x value was right here. Alright, and the important thing is x is a positive number and b is also positive, and then b never equal to 1. Alright, so let's try the number 3 to rewrite the following exponential equation in the logarithmic form. So we are converting it from the exponential equations to the logarithmic form. So this way. So we are solving for the exponents. So the exponent is x, okay, but we need to mention that x is coming from the exponent, so you have to put the log, and then always the base of the x is 4 next to the log, and then you put the y next to it. So that's the exponential and logarithmic form. For the b, 1.5 is not a base, so you gotta divide by 1.5 both sides. And then you got b over 1.5, which is 5 to the 8th power. So in order to solve for a is the log, because we need to mention that it's from the exponent, base 5 of b over 1.5. For c, now your exponent is now the 4t, which is a log, base is a 2 of m, but we need to solve for t, so divide by 4. Better way to write is, instead of the 1 over 4, you can say 1/4 of log, base 2 of m. For the d, divide by 3 both sides, because 3 is not a base. So q over 3 is 5 to the 2k power. And then exponent 2k is the log of the base of 5 over q over 3. And then you gotta divide by 2. And then you will get the k is 1/2 of the log base of 5 of q over 3. Okay? Alrighty, now the number 4. Without using your calculator, determine the estimate the value of the variable that makes the equation true. So the log is actually the by exponent, so instead of the 4, I need you to put the 4 as a 2 square, which means we know that this value becomes a 2. So because of that, you can say y is a 2. Same as here too. Log base of 9, but 81 is same as 1 over 9 square, which is still equal to t. If you're going to write again, base 9 of 9 to the negative 2, and then this becomes negative 2. Now you can say t is a negative 2. For the c, the problem is this value cannot be negative. Okay, so this value does not exist. Okay, alright, what about here? This one we can figure out the value of s. The problem is we cannot make the 10s 5 to the some power. I don't think it's easy, okay? So, but we can kind of guess out too. So because of the 10 is actually the between the 5 square and then 5, isn't it? So exponents for that is, we know that s is between the 1 and 2. Alright, let's go to the, we already talked about that in class though, but I want to talk about the property of the exponents, okay? So when you are multiplying two of the factor, you can write as adding the two exponents together. The property of exponent 2 is a quotient rule, which is when you're dividing it, and you can subtract the exponents with the same base of the beta. property of the exponent 3 is about power rule, and then you can multiply them out here. That's exactly the same as a logarithmic property too. So logarithmic property is that when you're multiplying it, we gotta adding the, because these are the exponents. The log is meaning of the exponent, so you're adding the two exponents just like a yx plus y. And then as a quotient, you can subtract it. See, quotient, you're subtracting the exponents. You're subtracting the exponents. As a power rule, where the c is also the exponent and log is exponents, you can just multiply them together too. Alright, that's what they're talking about, number 7 and 8, okay? And then number 9, I want to use that property to the simplify, okay? So when we have a sum of the ln's, I can just say ln x times x squared, which is now I can use a power rule, property number 3, I can say 2 ln x. So that's a final. In B, I have a base 3, and then it's a sum becomes a product. So you multiply, which is log base 3 of 10. And C is a quotient, so base of 4. You can put the 16 over 4. They have to have a common base though. But when you simplify, you got the base of 4, which is 1. And this one, actually, there's no way we can simplify as a same log because yeah, they have a different base, okay? So you can just say can be simplified. And then E is actually, we can simplify because all the log has a base 3. So now we can put the 9 and 4 multiplied together and then put the 6 on the bottom, which is a log base of 3 of 36 over 6, which becomes log base 3 of actually 6, which is we can't simplify anymore. And that one, they have the same base. The problem is log never can be a negative. So this is an undefined case, which means it's not, you cannot simplify this one. So which is this is because of the -3 of the log, and then this is the value of the undefined. All right, so that'll be all. Okay, thank you for listening.